So there's going to be, I remember last week there was a lot of background. This week there's going to be maybe even more background. And one of the things I'm really interested in, I think is going to really make for a fascinating sort of discussion today and on Thursday, is that there's a sense in which this paper is very explicitly in the business of trying to make philosophy useful for scientists. So I thought I would start by, because one thing you might note for those philosophers, for instance, who read the paper, you might have found it kind of quite surprising about the way it was written in some ways, the way the arguments were given in some ways. And I think a lot of that's explained by the fact that this is a paper that is really trying to use philosophical machinery and to present it in a way, I think, that's supposed to be, in some sense, convincing to scientists. I think that's really interesting. I have a nice picture of a tui here. This is a native New Zealand bird. Why is this here? Well, there's this classic old quote, which is almost every undergraduate philosophy of science course will say this. Lots of the case studies say this. This quote is apocryphally put to the physicist Feynman, but I'm pretty confident he didn't say it. Or at least there's no real evidence that he said it. But regardless, the quote is this, the philosophy of science is about as useful to scientists as ornithology is to birds. I think this is kind of an interesting quote because it seems to imply that ornithology isn't useful to birds. And it seems to me that ornithology conceivably could be quite useful to birds. But I take it the implication is that philosophy of science might be useful in some ways, but philosophy of science is in no way guiding to scientists. To be honest, I'm not actually too against this view. I mean, I don't think it's right, but I find myself thinking it sometimes. And at the times that I find myself thinking it is often when scientists themselves start referring to philosophy. There's this thing that happens when, one of the things you can tell sort of going on the background of this paper is that there's a certain place that a scientific debate gets to when they start throwing Popper at each other. They start kind of appealing to philosophy. And often when you see scientists doing that, that makes you go, okay, this debate is now not going anywhere or not doing anything. And I think that that's kind of too quick. And I think that one thing it really helps me reflect on, particularly in this paper, is the ways in which when scientists use philosophy, they're using them in very different ways than I would as a philosopher. And maybe learning how to make sense of that might help me be more useful to scientists, perhaps. And so the sort of background question here is something like, how might philosophical machinery, philosophical views, philosophical tools, in fact, be helpful for scientists? I thought I'd start with a kind of quote. This is still sort of warming up, a quote that I often sort of look at when I'm teaching the philosophy of ecology, which is a sort of standard sort of quote that you'll see in a certain type of scientific review paper. So this is from Jacob Wiener, and it's quite old, and I don't mean to suggest anything bad about Wiener himself here. I'm just using it as an example. And here's the quote. So he's worried about the sort of state of ecology. He's worried that ecology hasn't really progressed in various ways. And he has this sort of paragraph where he says, most of the criticisms of ecology over the past 25 years have been based on the Popperian notion of refutability. According to Popper, science advances by generating theories that make claims about the world, predictions that can be tested. The problem of induction cannot be solved, therefore nothing in empirical science can ever be proven. Theories can only be tested and at best not rejected. Scientific progress comes from generating better and better theories that survive ever more stringent tests, though in practice this whole process of rejecting and replacing theories may occur intermittently, then whole paradigms are changed rather than a slow continuous fashion. So as a philosopher of science, this paragraph is a wild ride where it seems to kind of both agree with Popper and Kuhn at the same time. We sort of shoot through the problem of induction on the way. None of the things that's said about these views is really what those views say or are. And it's kind of, it almost feels a bit like violence being done to the philosophers here by this kind of quote. But of course, the scientist is using the philosophy in a different kind of way. But I've kind of put this forward as just a sort of example of how this might work, of how sometimes scientists talk about philosophers. So what I'm going to do, in a way, before I get to the paper, is spend a bit of time having a go at explaining some of these 20th century views that they're kind of talking about. For some of you, this will be very, very old school, but hopefully the way I'll describe them might be interesting. For others of you, this might be kind of some useful background. One reason why I think it's useful to actually explain at least what I think Popper thinks or what I think Kuhn thinks is that often these are philosophers who have actually some really interesting aspects to their views that are often wildly misinterpreted. And so it's kind of nice to, at least out of respect to the work that they did, go like, here's what they actually thought. Or at least here's what Adrian thinks they actually thought. So as I said, this paper is a collaboration between Joyce Havstad, who we'll be talking to on Thursday, and a paleontologist of some description. It's always hard to tell which type of paleontologist you're dealing with, and as we learned last week with Max, Adrian doesn't seem to care. But their sort of opening question is a question about roughly theory change. And I thought this sort of nice quote sort of captured it really nicely. When you've got a consensus forming, when an agreement is being established, if you're a proponent of that debate, you're going to say it's a consensus. But if you're not happy with it, you're going to say it's a dogma, right? These are things I might say of the same patterns of scientific agreement. When a bunch of scientists start agreeing on something, should I describe this as consensus or should I describe it as mere dogma? Right? One's positively valenced and one's negatively valenced is one way of putting it. How do we tell those differences? One way of thinking it is, how do we tell when a change in science is in fact progressive, which is to say getting better, insert whatever you might mean by getting better, or in other words, how might we distinguish good science from bad science? And this takes us back to, like, classic undergraduate philosophy of science stuff, and I'm going to do some of that because it's fun. Okay, falsificationism. Here's the best photo of Karl Popper because he looks like a Bond villain and I like it. Falsification is a interesting view. It annoys me that we have to talk about it so often, but I do think it's kind of got some interesting features. It has this notion of being falsifiable. What is it to be falsifiable? Well, a hypothesis is falsifiable when there's at least one possible observation which could show that the hypothesis is false. Now, as we'll see, me saying show that it is false is actually a little bit too quick. A better way of putting it is, if there was an observation which somehow we knew it was veridical, that would lead us to be rationally compelled to reject that hypothesis. I'm going to go into this in a bit more detail, don't worry. And the idea is that being falsifiable is a necessary condition for a hypothesis being scientific. So Popper's not at this point doing the good science versus bad science. He's doing the demarcation. What's science? What isn't science? Well, here's a minimal condition, right? Here's what's necessary. It's got to be falsifiable. Notice here, here's one thing that people, I think, fundamentally misunderstand quite often about falsifiability. It's what a philosopher would call an intentional notion. You just need one possible observation, not an observation given current technology, not an observation that I can imagine, right? But it's got to be a possible observation. There has to be a set of circumstances that would clash with the predictions of the hypothesis, which is super broad, right? One thing to keep in mind is that lots and lots and lots of hypotheses are possibly falsifiable. It's also worth noting, going with its broadness, is that it's not actually telling us when something is scientific and when it isn't. It's merely telling us what a necessary condition for being scientific is. And the motivations Popper has for this are roughly two. One is to do with him taking the problem of induction, which we saw earlier, which I can describe in questions if you really want me to, but him taking that really, really seriously. And another is various examples of what's often called pseudoscience, various examples of folks doing things that look a bit like science, but are sort of in some sense illegitimate. And so that's sort of Popper's motivation here. But he's not just in the business of saying what's science and what isn't. He's also in the business of trying to say, when are you doing sort of good or bad science? So the thing to really get with Popper, the thing I think which is really crucial, is he really is thinking about science in sort of, if you want, logical terms, right? Science is resting on these deductive, rational kind of foundations. You're going to say that a hypothesis is kind of kosher, at least one of the necessary claims for being kosher is that it being falsifiable. And what you're doing, you're being a good scientist, is you're putting forward what he calls bold hypotheses. So one thing that's interesting about Popper, and what makes Popper and what makes me sort of similar to Popper, what makes Popper a little bit similar to me is that, as we saw last week, I tend to be really thinking about progress as being hypothesis driven, which is very different to the way that sort of Max Drezel was suggesting we should view it last week. But anyway, like a good scientist should be trying to put forward maximally bold hypotheses. And what makes a hypothesis bold is really to do with how many possible instances of falsification there are. So me saying that the same laws of gravitation apply to our solar system is less bold than the same laws of gravitation appeal to the entire universe, because one has more possible falsifying observations than the other. And so that's action guiding, right? Popper's saying, hey, scientist, be maximally bold. But here's the thing to sort of notice, right? So far, you can kind of see why this view might look attractive if you're the kind of scientist who really wants science to be somehow sort of objective, grounded in the truth, these kinds of things, because what you're doing is you're putting forward these brave hypotheses, and then they are being, tested and falsified and blah, blah, blah. But there's kind of a basic problem with this, right? Well, not problem, but ripple. And this is not an objection to Popper. People often think this is an objection to Popper, but it's actually just his view. So all P's are Q's. There's a hypothesis. Here's an observation. This P is not a Q, right? So all elephants live in Africa. Hey, here's an elephant that lives in India. Right? You might immediately think, well, there we go, falsified, right? This shows us that I have to give up that hypothesis. But actually, there are lots of instances where I have apparent observations that don't make friends with my hypothesis, and I might choose to think the observation's wrong, right? The observation is also, in some sense, a hypothesis. Both of them for Popper are conjectures. Right? I'm conjecturing that all P's are Q's, and then I'm making another conjecture that this particular P is not a Q. And I might disagree with either of those, right? What's kind of going on is both the hypotheses and the observations you have are themselves falsifiable statements. What's true for Popper is that they're mutually exclusive, right? They cannot be true at the same time. And that's what really matters. When we have these falsifying instances, what we have is clashes between conjectures, right? So one way of thinking about it is what I'm trying to do as a scientist is create the maximally coherent system that tracks the biggest number of observations I've made, right? So that means that refutation turns on us making a decision. Which of these big coherent things do I like the most is more or less what's going on. There are some rules that Popper tries to give us to try and say how to deal with refutations, but ultimately when Popper's thinking about refutations, what he ends up saying is, hey, it's a matter of community agreement. It's not to do with the kind of abstract logical rationality that he's often sort of using as a constraint. Ultimately, a lot of this, what you do within those constraints from rationality is kind of just up to scientific communities, which I think is really interesting because sort of the social epistemology of science is something which folks have only really started really caring a lot about in philosophy of science in the last sort of 20 years. But actually, Popper's a lot of it's sort of in Popper. And so when you're trying to do the way that sort of Popper tries to deal with refutations or when I should go for one or the other, he actually has a lot of machinery. It's quite rich in certain ways, right? So sometimes you be dogmatic. Sometimes you take things to be true for the purposes of some investigation. This is going to come in and matter when we finally get to Lakatos. He's got this sort of really interesting idea of a corroboration, which is very complicated for Popper. There's this idea that if a conjecture has survived a lot of tests, I should prefer it. But what he doesn't mean by that is that I should believe it in some sense. I shouldn't increase my credence in the truth of it. Rather, I should think that it just has fitting really nicely in with my big coherent system. And so there's this kind of very strange way that Popper, to my mind and to many people's minds, thinks about the way that confirmation works, which I could talk about. Well, he doesn't think there is confirmation, but we could talk about that if we wanted to. But fundamentally, there's this notion of communal agreement. Scientists agree amongst themselves about which hypotheses to agree and which to accept and which hypotheses to accept. The constraints on science, if you're Popper, are actually kind of minimal. It's just be consistent, build a coherent system. And And that's the view, which is actually, I hope you can see, very different to how scientists often speak about Popper. And also, to be honest, kind of different to how Popper's often taught in undergraduate classes. But that's at least my view on him. So, again, we're doing a first-year undergraduate philosophy of science module, so I've got to talk about Kuhn. So here's your man Kuhn. Kuhn has this word paradigms, causes all sorts of trouble, right? Here's one of Kuhn's extremely helpful statements about what a paradigm is. So what a paradigm is one way of thinking about it is that it's a kind of perspective, a way of seeing the kind of things that you learn when you learn to become a scientist, right? What a paradigm isn't is a theory, right? A paradigm is not an abstract theory in the sense that philosophers of science might often talk about it. Rather, a paradigm is kind of, maybe the theory's in there, but there's a whole bunch of other stuff as well. And so a paradigm is one way of thinking about it as a kind of set of sort of ontological things, what there is, methodological claims, how you find out about what there is, but also sort of richer, sort of tacit stuff. And the thing that's really important, I think, about the notion of a paradigm is it really captures the way in which you become a scientist through being socialized in various ways. So as he says, recognizing the sort of various bits and pieces of a paradigm is not acquired by exclusively verbal means. It's not that when you go to your undergraduate class becoming a archaeologist or a scientist or a philosopher for that matter, someone stands up and goes, here are the things we believe as archaeologists. That's what we do. No, what you do is you run up against a bunch of paradigm examples. Someone says, hey, here's how we do it, right? It comes as one is given words with concrete examples of how they function in use. Nature and words are kind of learned together. What results from this process is tacit knowledge, which is learned by doing science rather than acquiring the rules for doing it. So science education is often really boring in a certain way. It's, hey, do this experiment, resolve this mathematical equation, do this over and over and over again. What's going on? Well, part of what's going on is you're learning about the kinds of solutions you want and the kind of problems you should find interesting. I think this very clearly happens in sort of philosophical teaching, right? I tend to be I've learned in the analytic philosophical tradition. What did that involve? Well, some people said, hey, here's what the interesting questions look like. Here's what good answers to those questions look like. Let's do that for 3 or 4 years. And I come out the other end thinking like that. Anytime I see a nail, I make sure that it looks like a philosophical hammer and hit it, right? Same thing with science. Notice that we've already spoken a lot about the kind of role of tacit knowledge in the way that archaeological and paleontological work is constructed. We thought about that with Caitlin, and we also thought about that when we were thinking about experimental archaeology. And so Kuhn is, in a sense, taking the stuff, but being much more ambitious with it. This type of kind of learning is fundamental to the sort of pedagogy of science, and that pedagogy is fundamental to what science ends up looking like and the kind of structure that it has. So for me, there's this really big difference in terms of the way that Popper and Kuhn are even having this conversation. So Popper is really thinking about science in propositional terms, right? There are explicit theories that are, if you want, even sets of sentences that have these sort of logical relations, and we care about things like coherence. Whereas Kuhn is kind of thinking about it as, if you want, a kind of perspective. There are certain types of a set of questions we have, and there are certain answers that about what, certain expectations about what good answers might look like, right? And these are very different ways of thinking about it. And again, I should say, these are both really complicated philosophers who say a whole bunch of different things through their careers, right? In a sense, when I say this is what they think, to an extent, what I'm really doing is going, here are the bits of them that I like, and here are the kinds of interpretations of them that I like. So take all this with a big grain of salt, as you should anytime someone is talking about the history of their own discipline. So the big thing with Kuhn, in a sense, is he's really both a philosopher and an historian. And as a philosopher historian, what he's trying to do is give us a framework that we can use to understand the history of science. And he has this sort of very famous, very kind of slightly annoying framework, which goes a little bit like this. You've got early old stuff, people are just futzing around. There isn't really, people are trying different stuff. There isn't really a community yet. You then have a kind of paradigm event. Someone has a successful exemplar. So for instance, in the case of archaeology, people might point to sort of early studies in the early 20th century where people were first like, I should have thought of this, there are actual names of people that I don't have in my head right now, but the folks who first went, hey, what if I measured everything out and actually kept track of the position of the objects and actually sort of collected all the objects, so then I could have all that sort of data. You might think of that as a kind of paradigm instance. And what happens is people point at it and go, that's how you do it, right? That acts as an exemplar for good, in this case, archaeology, right? And you could think about, Newton's Principia seems like a good example as well of a case where people were like, damn, that's how you do physics. And this then creates a sort of paradigm, what's often called normal science, where basically you have a set of problems that are the things you gain and a set of kinds of solutions that you want to give. And what it is to be working within normal science is to be solving those problems, right? There are ways in which the sort of set of theories you have, the sort of perspective you have, doesn't fit into the world right. And so what you're doing in normal science is trying to fit it to the world. Off you go. After a while, problems arise, so you have what is often called a crisis. So there's an increase in the number of anomalies, things that just aren't playing with your paradigm properly. This builds up, this builds up, this builds up, and then it all crashes down, right? Basically, what happens is a new paradigm kind of arises, there's a revolution, and you go back to you have another paradigm event, right? And this is this kind of, it's very hard to know exactly what to think about this model, because increasingly, anytime, this is way too simple to actually track the actual history of science, right? This is a very normative model, if you want. And most historians of science that I've talked to are extremely suspicious of the idea of this even working in the instances that Kuhn tried to apply it to. But then historians are notorious killjoys, so of course they would say that. So what can we say about Kuhn? So we have a notion of progress, which is something that happens within normal science, right? It happens within sort of problem solving. And so what you're basically doing is getting various observations, other kind of problems, other challenges, and you're kind of trying to fit them to the paradigm. But the sort of crucial thing the thing that people got very annoyed about, I guess, about Kuhn's work is this idea that you can't have progress between paradigms because they're incommensurable. Now, I'm not going to talk much about what he means by incommensurable because he means a bazillion things, but the basic idea seems to be something like this. The only way you can measure something's success, the success of a paradigm, is in terms of kind of problem solving, right? You can say, is that paradigm doing well? Well, all I can do is go, well, here's the set of problems and here's the set of solutions, right? Right? Problem solving is internal to a paradigm, right? Different paradigms have different problem sets, different standards, terms mean different things, right? And that's not wildly implausible, right? When you're going between different versions of, different sciences, the terms mean different things, but it's not just the different terms, because those can just be translated, in my view. It's also that the standards are different. What good science looks like seems to change. In virtue of that, it seems that we can't judge progress between paradigms. And then there's this kind of implication that different paradigms are not more true than each other. And I want to note that 4 doesn't follow from the rest of that argument, right? I don't know where truth comes from, right? Here we're just talking about progress. This is going to come up again at the very, very end. What people think these days, people are very skeptical of the historical stuff and very skeptical of the incommensurability stuff. When I say people, I mean people within the philosophy of science. And again, I'm speaking I've not done a poll, just speaking anecdotally. I think it's fair to say that people are very skeptical of this. And I think for very good reason, right? Again, I think it's too simple a model to capture the richness of science's history, but also I think that incommensurability is way too strong, right? Humans are very good at communicating with each other, right? But people, I think, take normal science fairly seriously, much more seriously than they used to. It used to be the case, if you read like a philosophy of science textbook from 20 years ago, someone would they wouldn't say very much about normal science, but nowadays there are sort of whole chapters in philosophy of science textbooks that are specifically devoted to this normal science stuff. And the reason is, I take it, people are taking this kind of scientific learning as a kind of socialized pedagogical process much more seriously than they used to. So that's what people kind of think about Kuhn at this point. Now, finally, after 20, 25 minutes or something, we can get to Lakatos. And I think hopefully you can see there's a reason why you want to explain Kuhn and Popper before you get to Lakatos. Because the real sense in which Lakatos is really building on these folks, right? This is a very standard sort of narrative that you get when you talk about 20th century philosophy of science regarding theory change, right? And so Lakatos can be kind of understood in a way as trying to sort of update various things about, in a sense, Popper. As a bit of sort of, so far as I understand it, Popper very much didn't like Lakatos because Popper thought Lakatos was just saying the same thing that Popper said. I think that's a bit unfair on Popper's part. But anyway, the kind of idea, and if you've read the paper, this should now be very familiar, is you have this sort of, somehow this core, you have a set of unquestioned theoretical commitments, right? As a philosopher, an analytic philosopher, part of my core, 15 years ago would have been classical logic, whereas nowadays we go all the logic or something, right? And that core is sort of defended in a certain way by a belt of auxiliary hypotheses. They're these sort of other hypotheses which are not sort of things I'm absolutely committed to, but they're things that fit with my core, that are consistent with it, but they're things that I'm willing to sort of give up in certain ways. I have a set of positive heuristics. What the positive heuristics do is they sort of tell me how to generate new sort of speculative hypotheses, right? And so if you yourself are, one way of thinking about how this might work is, as a philosopher, I have a set of positive heuristics to do with how arguments work and how you question premises. As an archaeologist, you might have some interesting heuristics to do with, what sorts of digs you should do, what sorts of questions you should ask of your specimen, stuff like that. What it does is it takes you from your sort of core to stretch out into these sort of speculative, if you want, hypotheses. And those then are tested. Sometimes the test goes great. They get corroborated and you get to pop them into either your belt of auxiliary hypotheses and eventually your core, right? And you also sometimes have a lack of corroboration. Then you have a bunch of negative heuristics, right? How do I alter my belt in order to protect the core given those anomalous results, right? So when stuff doesn't work, what do I need to change in order to make sure I'm staying consistent? So hopefully you can see, like, hey, this looks a lot like Popper, right? It's just got a bit more structure to it in various ways. And I think it's kind of a really interesting sort of way of doing business. Like, I kind of find Lakatos pretty interesting. And he has this distinction between sort of progressive science and, what does he call it? Yeah, degenerate science. And I always find it the term degenerate, of course, the only people who use the word degenerate are people of a certain very, very right-wing persuasion and philosophers of science talking about Lakatos. So it's very weird. But basically, progressive science, progressive science proceeds by generating those great speculative hypotheses. Some of them become part of a body of established knowledge, and others lead to alterations of that protective belt. That's a kind of process that we should identify with progressive science, whereas degenerative science doesn't do it, right? Basically, it doesn't generate new stuff. Or when it does generate hypotheses, they just turn out to be false, right? And Lakatos's idea is, progressive science good, degenerate science bad, roughly, right? And this is interesting. It's a really interesting way of thinking about how to understand theory choice, right? When do we have a good theory? When do we have sort of a good body of theory? Oh, it's when they're doing all that stuff, when they're being progressive, they're generating new things, they're testing them, the theory is growing and building. When is it bad? When it's static, right? I'm sure there's lots of interesting things to say about politics and stuff behind Lakatos. Okay, so this is a wild ride, this lecture. So we've got a bunch of philosophical machinery on the table. I want to spend a couple of minutes talking about why this stupid thing about whether birds are dinosaurs matters and why it might matter. And I think it actually matters a lot once we kind of see the ways that paleontologists generate knowledge, at least in this type of context, in the context of vertebrate paleontology. So here's the sort of famous, beautiful sort of Archaeopteryx of 19th century find. Very pretty, often identified as the first bird. And our question is this bird a dinosaur, which is to say, is it part of a clade that includes dinosaurs, or is it some kind of side branch? Right, so here is an entirely accurate representation of the clade called the Archosaura. Now, a clade can be thought of as a single ancestor and all of their descendants. It's got to include all of them. And the Archosaurs are defined as basically your crocodiles and your birds. So the Archosaurs have got to include the common ancestor of crocodiles and birds and everyone else that falls within that range, right? So for instance, at some point along the line that includes birds, we have the pterosaurs coming off. The reason that the pterosaurs are not dinosaurs is because they are the clade there's a clade that has the dinosaurs that doesn't have pterosaurs in it. Now here's the dinosaurs are not birds view. All right, birds are not dinosaurs view. Damn it. On this kind of view, you have the line that becomes birds, and there's a different line that becomes dinosaurs. Very roughly, here's the birds are dinosaurs view. Again, this is an entirely accurate phylogeny. This is just how things look. There's the sort of, as it were, the birds are within the dinosaurs is one way of thinking about it. And there's something kind of often sort of esoteric, it almost feels like, when paleontologists are arguing about this. Why should I care whether or not this bunch of animals have that relation as opposed to another relation? Well, I think actually we should care a lot. So first off, as we've said, a clade consists in an ancestor and all of their descendants. This is just a sort of way that sort of trees of life are sort of constructed. If you're a paleontologist, you're using morphological information. You're sort of saying, hey, who belongs to which clade, right? Which is why there's all this futzing about with feathers and so on and so forth. Roughly, you've got these patterns of variation within your specimen. You've got things with feathers, without feathers, and so on and so forth. And what you're doing is you're trying to construct the clades, right? What you want to do is find the ancestral signal that exists in that morphology, right? So you have to think about the similarities that are due to shared ancestry and the similarities that are not due to shared ancestry, right? So if feathers evolve convergently, then they're not a signal of shared ancestry, right? And that's really important for me to be able to sort of construct the tree correctly. And the way that this is often done is by more or less comparing a whole bunch of possible trees and then trying to maximize certain properties that they think track the real clade, right? So cladistic parsimony is one example, right? The tree that has the least branching events is the one that you should prefer. Now, I want to note here that I'm doing a very realist reading of this. I'm saying that if you're doing phylogenetics, you're finding an ancestral signal. I'm saying that you're trying to find the real tree. This is fairly controversial, but it shouldn't be. I think it's very straightforward that this is what paleontologists are in the business of doing, despite what they think. What you end up doing when you do this process is you end up dividing traits into sort of basal or primitive traits, those things that are held by the ancestors and those that are derived. Knowing what is basal and what is derived and knowing the sort of sequences by which these things evolve is so important for so much of the stuff that vertebrate paleontologists do. Right? We're not just getting who is related to who. This looks boring if it's just where exactly do birds fit into the tree. But where birds fit into the tree is crucially important for asking a whole bunch of funky questions. One thing it does is it sets the order of evolutionary explanation. If it turns out that wings are basal, if it turns out that they all had wings, well, then I don't need to explain the evolution of wings in that particular group. I need to explain it earlier on. We get these sequences of transformation in the morphology, which is crucially important for me trying to understand how these things evolve. If you want to know how you evolve a wing, you want to know when it evolves, and you want to know what kinds of sequences you get in that evolution. It also helps us sort of detect patterns, right? If it turns out that lots of critters are kind of evolving wings all over the place, right? If there's heaps of convergence, this tells us something really important about the evolvability of wings, at least in that context. Also, it helps us find things like, for instance, Cope's law, which is the idea that the individuals in a species or in a lineage, I'm going to say, get larger as time goes by, right? You need to be able to resolve the phylogeny in order to detect those patterns, right? And also provides as a basis for comparing between all these different types of taxa. So actually, if you're interested in like birds and wings and all of this stuff, whether or not they're dinosaurs and whether or not they're not dinosaurs is actually crucially important, right? Just to point at a thing, I talk about this kind of stuff a lot in this recent kind of dodgy book that I wrote. If you want a copy of it, let me know. Cool. So we have these sort of two views: the view that the Archosaur tree has dinosaurs splitting from birds, and the Archosaur tree having dinosaurs and birds sort of the birds nestled within the dinosaurs, right? How should we judge between these views? Well, what's kind of interesting, roughly the argument of this paper is, hey, this is a degenerate research program. The one where you say dinosaurs aren't birds isn't working well according to this kind of analysis. And I think one of the more telling bits where they're describing this is when they talk about the sort of big upset in this debate in the early 2000s when fossils are found in China where they're just blatantly dinosaurs with feathers. Right? Just very straightforwardly, hey, these dinosaurs have just feathers all over the place. This seems like big trouble, like really big trouble for this view that says that dinosaurs aren't birds. And one of the moves they make is really fascinating. What they do is they say, that's because all these things that you think are dinosaurs are actually birds. It's just that they're birds with very dinosaur convergent traits. So you've been misinterpreting the dinosaur-like features of these animals as being a signal of ancestry, when actually it's convergence, right? Which is a wild move. I really like this as a move. It's fine. To keep my hypothesis, we can just totally restructure the dinosaur tree. All of these things that we thought were dinosaurs are actually birds. And so Bambiraptor turns out to be a bird. So that's great. I really like that. And this has a sort of almost an air, I mean, I'm being a bit mean here, but it's almost an air of desperation to it as a move, right? At least as it's described in the paper. I like it. I like that. I mean, what might Popper say about this? Well, hey, they're being maximally consistent. They're just making a different judgment about which maximally consistent set of things to accept. So, don't know. And so the way they give the argument, I think, is really interesting. And I think it speaks to this difference between the way that you might write a paper for philosophers and you might write a paper for scientists. Because as a philosopher, I'm like, they don't actually cash out the crucial bit of the argument. They just give me a diagram. And as a philosopher, I'm like, what do I do with a diagram, right? Whereas scientists are like, diagrams, sweet. I'm going to spend a bit of time looking at the diagram and then I'll understand the argument. That's too quick. But very roughly, that sort of seems to be the way that these things go. And I think it's really interesting that they chose to present the argument in the way that they did. But very roughly, we have this kind of cute historical reconstruction, right? Where you're going through from 1868 through to, basically now. This is the dinosaurs, birds are dinosaurs kind of view. And you sort of see this idea as these new sort of discoveries come online, they're putting out different hypotheses, they're learning more stuff, some things are being discarded, but it looks very dynamic and it looks like it's kind of getting a sort of solid core, right, as we go through. For reasons of time, I'm not going to go into much detail. And the idea is we just compare that to what we see with the birds are dinosaurs, birds are not dinosaurs, band, and we see that there's just much less going on. And you don't crucially see these ideas forming that kind of protective core. You don't see that kind of research program. So as they say, one thing I want to point out here is what they don't say is that we shouldn't believe this view. They don't say, they're very careful about their exact claim. They say, it is highly unlikely that either a straightforward degenerate or a static version of the banned research program will flourish. Without further generation of empirically confirmable speculative hypotheses and at least occasional corroboration of those hypotheses. And given the recent competitiveness, recent history of birds are dinosaurs, it is far more likely that that one will flourish instead. So they're not saying anything about whether one's true or one's false, whether you should believe one or believe the other. They're saying, if you want to bet on one, bet on birds are dinosaurs. So here's their argument, as I've structured. What I'm going to do for the next, very quickly for sort of 5 minutes before we have our break, is I'm going to sort of do a very this tells you the sort of philosopher I am. I quite like putting things in semi-formal arguments and then finding out where I can poke holes in those arguments. So one part of their argument, one of their premises, is that BAND is a degenerate or at least static research program. And, BADM is a progressive research program. That's what I take it we're supposed to learn from those two histories. These are competing research programs. They both cannot be true. I think that might matter for their argument. I'm not entirely sure. When you're faced with competing research programs which in fact are competitors, we should prefer progressive programs to degenerate ones. Therefore, we should prefer one over the other. Okay, so the sort of game that you play when you're a philosopher and you're working through the semi-formal stuff is basically these premises are opportunities for us to go and, find ways of either disagreeing or strengthening the premises. So one thing you might think is that there's a kind of way, a really fun way of objecting is to dive into the history, right? Is to go and look at this idea of being degenerate and the idea of being progressive and find arguments, one way or the other, which is a really fun sort of framing for an historical project, I think. I'd really want to see a paper that comes in and tries to disagree with those historical claims. But I think there's another thing that initially confused me about the paper, which is when you think about research programs, you're thinking about like Lakatos has in mind like stuff from physics, right? Lakatos is thinking like, things about inertia, like these like theories. And you might think that that birds are related to dinosaurs is a really weird thing to have as your core of your research program. That kind of seems odd. It's very different to the sort of thing that Lakatos talks about. But I actually think that when you think about, one of the reasons why I went through the importance of thinking about the phylogenetic position of birds within dinosaurs, actually it does form a core commitment. If I don't think that birds are dinosaurs, then the way that I go about understanding the evolution of feathers and lots of other things suddenly look fundamentally different. And so actually, I think it does look like a core. It's just a really kind of surprising one, given the sort of stuff that Lakatos was talking about, which I think is interesting. So there's a bunch of ways you might reject those first two premises. This one is kind of tricky, right? I'm all about trying to find surprising ways in which things might be consistent. And I think the way in which there's that really interesting move where birds are not dinosaur people start completely rearranging the phylogeny looks like an interesting case where you might think they're not competing. You could also take a line from sort of Hasok Chang's book and say something like, actually, insofar as we can, we should have a diversity of different research programs going. And so I shouldn't prefer one over the other just because one's at the moment being a bit more progressive, right? So there are some ways you might claim, oh, that's the fourth, sorry, I've shifted the fourth premise halfway through, dearie me. So I don't think there's much to say about 3, but I think there's a lot to say about 4. And I'm just going to give you some initial thoughts. One thing you might say is, when we're talking about preference, right? Preference could mean a lot of things, right? When Popper says we should have a preference for well-corroborated theories, he doesn't mean we should think that they're true or even think that they're likely to be true. He thinks something else. I'm not sure entirely what attitude you're supposed to have, but there are lots of ways of preference. And so one thing that you might always worry about here is, well, it could be that the birds are dinosaurs has been a progressive research program because it's had more people doing it, it's had more money, it's had just more work being done. The reason that we're not seeing that with birds are not dinosaurs is because there's only a few people doing it, they're not encouraged to do it, etc., etc. Science is massively influenced by people's interests, interests in the sort of, seditious power-based sort of sense, and by fashion in various kinds of ways. We see this in the history of science very, very often. And so there's a worry that this thing only looks progressive because people put a lot of money into it, right? And so we might give, and here I'm going to use some machinery that I'm not very happy with, but it helps me put the point out. You might give a sort of sociological explanation, which is to say, hey, that's just how the incentives work, right? That's just why things got pushed in that direction. Right? Why was the Manhattan Project so successful? Well, a pretty serious amount of America's GDP went into that, right? One thing you might say is, hey, the reason so much progress was made was huge amounts of money got put into it. Insert all of your favorite moonshot examples. One of the things that's going on with the moonshots is people have huge amounts of money. But there might also be an epistemic explanation, right? So epistemic and sociological explanations need not be competitors, but I take it the thing we want is something like there are some legitimate epistemic values that the research program embodies, right? Why birds are dinosaurs is so productive, it's so progressive. Hopefully it's not just because lots of people work on it. Actually, there are some real legitimate epistemic values that it embodies. That's what we're kind of looking for. But this notion of preference here, right? What sort of preferences might we have, right? What do we mean, right? And one sort of big thing going on in the background here is surely what we want to know is whether or not the core is true, right? And so there's this big question always sitting in the back of the sort of Lakatoshian stuff, which is, well, what's the link between being progressive and being true or veridical or empirically adequate? Pick your favorite stand-in for being true if the T word makes you scared, right? Because that would be a real clincher if there was some way of doing it, right? And so one way of thinking about Lakatosh's work, so certainly post-Lakatosh, this was how he was often interpreted, is that he's talking about not what we should believe, but what we should bet on when we're distributing our epistemic resources, right? You could interpret the argument as saying, hey, I'm not saying whether or not birds are dinosaurs. I'm saying if you want to have a successful research, you should bet on birds being dinosaurs, or at least that research program. So to quickly wrap up and to give you some closing thoughts before I collapse on the floor and we have a 5-minute break, one way of thinking about what Havstad and Smith are doing is they're trying to develop, just to be poetic, an ornithology that's useful for birds, right? Scientists often have these kinds of debates where they start throwing philosophy at each other. What sort of philosophy should they use and how should they do it? And one thing I find really interesting about their project is that it's a crucially historical one. You really need to look at how you have to have an historical narrative about how these various hypotheses and discoveries kind of built up. And I really like the idea that sometimes when scientists are trying to make decisions about which theories should be accepted, that they should be thinking about seriously the history that kind of got them there. I think that's a really interesting kind of thought, right? One upshot of this, of course, means that actually it's only going to work after a whole bunch of stuff has been done, right? This isn't going to help us in like early on in these kinds of projects, right? In fact, you might think that there's an argument here for trying heaps of stuff, right? You might think that we should have lots and lots and lots of different sort of possible research programs going, at least for a bit, in order to find out whether they work or not, which I think is kind of cool. And you know, for any philosopher of science, there's a sort of dreaded meta-induction lying under the surface here, right? If you want to say that you should really accept these because you think they're going to lead to truth or something like that, that relies a sort of complex sort of discussion, right? You have to be basing it on something like a history of inferential success in that research program, and that giving us reason to think it will continue to have that success. And moreover, perhaps, for us to believe in the truth or the verticality of that research program. Whew. So that was me giving you kind of what I take to be hopefully useful framing for the paper. Let's come back on the hour in 5 minutes and we'll talk about it. Thanks. So as we wait for people to sort of come on in, as per usual, we've got sort of half an hour or so for discussion, assuming like there's enough juice to keep it going from there. Yeah, I guess I will sort of sit here and wait for hands or various other ways of getting my attention. Yeah, Joe, do you want to start?
Yeah, thanks. Yeah, I was wondering about how to conceive of the core, particularly with regard to the birds are or are not dinosaurs debate, or maybe even more broadly, because partly my thought comes out of the idea that there's a whole bunch that the birds are or are not dinosaurs folks are going to agree on, right? And so so you might think, well, there's some shared core of beliefs, and so hey, maybe it's more likely that what they're disagreeing on is something in the periphery. But then that gets me to think, well, maybe core, it's a sort of relative notion. It kind of depends on who you're debating with, who you're disagreeing with, what the competing research projects are or something. And so I wonder if you'd think it'd make, I don't know, if there's room for us to think of the core as something that depends on the context and in that sort of way. I don't know. Could you?
Yeah, but that was exactly one of the sorts of questions I wanted to ask Joyce, right? Because if you think of them, like the more you sort of reify the core, the more weird it starts looking, right? So how am I supposed to, you think about, as you say, given the amount of agreements, there's huge amounts of agreements between the birds are dinosaurs and birds are not dinosaurs people. So how do you represent that? Like, are the cores partially overlapping? Well, that doesn't seem right because there are these sort of huge differences. And so my immediate reaction is to go somewhere like where you went, which is to say, look, cores are kind of organizing principles or something like that, and how you want to use them is really going to turn on what particular aspect you're interested in. And so there might be some contexts where the research program is going to include all of those people and there might be sort of other contexts where they disagree, but that actually starts to really sort of futz with the mechanics, right? Because at least if you're thinking about Lakatos in the sort of Popperian way, like the way that Lakatos probably intended, you can't have inconsistencies, right? And you just straightforwardly do if you're kind of thinking about that. So I worry a little bit that it might be that once you start sort of thinking about it in that more relaxed way, some of the more the logical constraints fall away. Now, I don't care about those constraints, so I just think Popper's wrong about consistency being as important as sort of he thinks it is. But that's certainly a sort of potential cost that you pay. But yeah, like I think it's, generally speaking, it's very hard to know once you go outside of the sort of context that Lakatos is often talking about, where it's like, hey, here's some physical theory. Suddenly what counts as being in the core and what doesn't starts to get really confusing. Yeah, if you want to come back on that, you're welcome to.
No, I think that sounds plausible. And I mean, I think from what I understand, philosophy of science has moved further and further away from the sort of deductivist logical constraints of Popper. So that feels natural to me.
Yeah.
And maybe there's some interesting work to be done in providing a sort of alternative Lakatos-esque view that's less logically demanding, I guess, less trying to maintain the Popper stuff. So no, that sounds right to me.
Yeah, I think that's right. And so, yeah, so one thing, just a bit of background for everyone, one thing that's kind of funny for me about this paper is that, I mean, my immediate reaction to someone using Lakatos, and I've seen like Joyce presented this paper at a workshop that I was at, and I was just like, what? Like, this is so sort of old school, and like, what are you talking about? And there's a sort of interesting bit of the paper where they sort of point out that Lakatos dies like wildly young. And I think there's this kind of, I think in the back of her mind, there's this kind of idea that he would have gotten to somewhere that's more like this, that's more sort of, and I think that's interesting. I think it's kind of fair to be like, to be able to adapt Lakatos, but this is definitely, I don't think this would not count as orthodox Lakatos.
Cool, thanks.
Yeah, so Sarah?
Yeah, I wasn't planning to talk about cores, but I just want to comment that, within scientific teams, I think the kind of idea of a core becomes more straightforward in that just how scientific teams are organized. You have like a principal investigator in these teams who usually have a kind of core idea that they share. And so in some ways you end up getting like camps of scientists. And so it's usually pretty clear what the major feud disagreement is, just from a practical, like sociological sense on what the core is. It's usually well known among the scientists where the, heart of the feud lies. And I think in some senses you can consider that the core. But anyway, what I was going to say is that I found this paper quite compelling in that, I could think of several like kind of current examples that I've encountered. Like within geology, we have a debate over like hotspot volcanoes, which you've probably heard of as like Hawaii being like a mantle upwelling.
Yep.
And that's like a common theory in geology, but at Durham they just don't like it, and they're just known as the people who don't do hotspots, and they have all their own like geology that is completely different from everybody else, because it's quite a fundamental part of like continental drift and all those things.
Yeah,
and
I was thinking
sense, like I could.
Yeah. Oh, sorry, you keep going.
No, go ahead.
Oh, I guess I was just going to say, yeah, like I've been to a conference that was on realism and historical science, and it was in Durham, and the Durham geologists came in and gave some talks, and that was really interesting from a kind of very similar dynamics, right? So part of this, I mean, it's a really interesting sort of type of dispute you get in science, which both the one that Joyce is talking about and the one you've brought up have the similar structure, where basically you have to do these quite radical revisions of a bunch of things that are more or less accepted kind of ideas in order to get your idea to kind of work. But it's also in this way where it's often unclear. And once you put it in terms of progressiveness, right? Once you put it in those Lakatoshian terms, you seem to very quickly see what's kind of going wrong. So these people who are just positing these weird mantle plumes left, right, and center, it suddenly starts looking kind of really like somehow not productive, right? And so I do think there's a lot more to say about maybe characterizing this particular type of scientific dispute, where you have a side which is very much going against the grain, but at the same time in a way that seems to not be very progressive. And there's an interesting question there about, is the reason that they're not progressive because they're having to go against the grain, right? That might be the sort of, that's the conspiracy theorist response, right? Well, of course they're not getting anywhere. It's because the mainstream are quashing them. And I find that pretty implausible, actually. Feel free to come back if you...
Yeah, yes and no, because my other thing was the second example that kind of immediately came to mind was like the ether back in the day, you know, when there was so much scientific work centered around the concept of ether and everything was built on that idea and nobody really could go against it. And in a way that was very progressivist, or however you want to put it, you know, they were building a lot of our modern physics and chemistry and making huge discoveries all based on this completely bogus idea that space is filled with ether.
Yeah. So sorry.
Who went against it? I mean, you could say that that was degenerative. You know, they have to break down everything that's known about science, and they're going against the grain, and they're not getting anywhere for a long time. You know.
Yeah.
But the progress wasn't that good in the end, right? Because it all came tumbling down.
Yeah, I guess I wouldn't. So my view on this is something like, I think it's a mistake to think that it all comes tumbling down. It's just that it turns out the ether isn't there, right? So they get rid of that bit, but actually a lot of what was discussed was kept. One thing that's kind of, I mentioned Hasok Chang during the discussion. So he has a sort of lovely sort of this view about phlogiston, which is another one of these things that we used to believe and we were silly and blah, 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 where his view is, hey, actually it should have kept going. Right, he thinks that we shouldn't have given up on it. We should have let that research program continue, which is really interesting. That's an interesting sort of idea. And one thing that's kind of, I think, nice about the Lakatoshian machinery, perhaps, is it gives us some ways to start kind of very early, messy, very coarse-grained ways of maybe starting to think about how these different research programs might sort of interact with each other, and also how we might start judging them. So I think it might be a fun tool from a history of science perspective, maybe, although historians of science might think that it's a bit crap for, it's going to need a lot of work, let's put it that way. But I think at least the reconstruction they do historically is fascinating from a methodological standpoint. I wanted to say something about, I really like the point you made, Sarah, about the ways in which you can think about research programs as sort of not quite constituted by, but arising from sort of teams and sort of team composition as well, right? Because a lot of the way that at least paleontological groups often work is they're like, what's our expertise? Who do we have who can do what? You know, if you've got a paleobotanist, you're a very different team to a team who doesn't have a paleobotanist, for instance, because you're just able to do more interesting things. And so I really like the idea that the right sort of, or a really interesting locus for sort of thinking about where the cores are is to think of them in terms of the sort of the group, and in particular the PI is often doing, depending on how dictatorial the PI is, they're often doing a lot of work in terms of what's taken as a given assumption in that group. So that's a really interesting thought. We should move to the big room.
Thank you for this article. It's really interesting and clear one for me as an archaeologist. So for archaeology, it is also important to think about communal mode of knowledge production in archaeological excavation. But my question was different one. Can you explain a bit how you understand this difference between pseudoscience and bad science? For example, I'm thinking about racial anthropology. So how we consider that a part of history of science.
Yes, yes. So I didn't. I mean, I didn't talk about pseudoscience in part because it annoys me. Okay. So certainly a lot of the motivations that sort of Popper has, at least when he's in his more popularizing mood, and less in his like, I'm doing the hardcore philosophy kind of mood, is this sort of need to try and demarcate sort of what is science and what isn't science. And people often sort of talk like this sort of outside of the philosophy of science, right? And very occasionally you get kind of projects that try and like people try and think that we can do another spin of the wheel here and have another go at trying to solve the demarcation problem. But I think it's basically received wisdom in the philosophy of science that it's kind of just a waste of time. And it's a waste of time because I think the idea is this: the kind of answer that you get from the philosophy of science might like, it's just a grab bag of stuff, right? There isn't a thing that makes something science and a thing that makes it not be science in the way that in a way that philosophers would find a useful answer, right? So you could talk about science in terms of the institutions. You could say, well, actually there are, what a scientist is someone who publishes in these journals and is part of this sort of institution and maybe part of this type of intellectual tradition or something like that. And I think that's probably the best we can get to. But if you're talking about and I don't think that's a bad answer, actually. I think the answer that talks about science as an historical entity can actually get you a long way towards sort of understanding the various social processes and social practices that might make you then be able to sort of say, this is what makes this kind of a good science. But anyway, certainly, like if you're someone like Popper and a bunch of other people in the 20th century, you want to be able to say, hey, here is the mark of science. And I guess, in a sense, if we could have that, that would be great. If it just turned out that there was this like simple test I could do that just, if I had like a reader that just boop, 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 and it would just tell me whether something was science or not, that would be super useful. But it turns out that's not how it works. It turns out that science is a way too complicated, way too human sort of process. One way of putting it, I mean, here's a cheap way of putting it, I guess. I think that that justification is wildly contextual. What makes something justified or not really turns on a lot of deep, rich information about the context in which that claim is being made. Simply in virtue of that, I can't give you a general story about when something is justified and when it isn't. I'm always going to find a case where a sort of wild conspiracy theorist is doing something that kind of looks a bit like a thing a scientist is doing, and the difference is always sort of to do with context. So a quick example, Derek Turner and Michelle Turner, his partner, she's an archaeologist, have a really beautiful paper where they talk about the conspiracy theories, the ancient aliens conspiracy theory in archaeology. Well, not in archaeology, so the pyramids are built by aliens, that stuff. And the point that they make, which I think is really interesting and I think quite deep about what's different between the way that archaeologists think about their targets of study and the way that ancient aliens people do, is that what archaeologists are all about, or not all about, I'm sorry for generalizing, are often about, is really richly contextualizing these objects within the surrounding body of knowledge. And what the ancient aliens folks exactly do is not that. What you do is abstract it from all that rich kind of extra sort of context. And so they have this nice account of one of the things that makes, one of the markers of legitimate science in cases like archaeology is to do with the way that you contextualize. And I think that's kind of quite interesting. But what it's not going to do is serve as a marker that's going to tell you between science and pseudoscience more generally, because of course there's lots of sciences where people don't do that kind of contextualizing. What else is doing an experiment other than trying to decontextualize a particular experimental phenomena and from its sort of natural occurrence, right? And so I just don't think such generalizations are to be had, and they more or less have to be dealt with on a sort of case-by-case basis. You kind of just, or maybe at best you could have a set of heuristics. If that, feel free to come back, of course, if that didn't quite speak to what you were looking for.
That's fine. Probably Alexander will continue my thought.
Brilliant. Well, Alexander, why don't you continue the thought or introduce a new one? You're muted.
Yes. Well, I think that Monica was trying to make a point about what we call not only pseudoscience, but sort of pathological science. That's not my term. It's Gerald Holton who said it's sort of sick science, where it's not fraud. Scientists are conducting real scientific research. They're believing that their own wrong results for a reason are prejudice, and this kind of science is often for example, you just mentioned in archaeology and astronauts and aliens creating whole civilization on Earth, or some sort of conspiracy theories. So then we are back to square one, how to oppose such kind of pathological science, if not by very simple means that Popper was introducing, or Lakatos as some sort of hypothesis, falsifiability or something like that. So that is the problem we are actually dealing with, and it's not only a philosophical problem, but a very real problem that we have in our scientific practice.
Brilliant. Yeah. So it turns out how you decide what is science, what isn't science, has enormous practical sort of upshot. So there's a sort of famous and frankly kind of embarrassing case where in one of the big, I'm sure probably Joe or someone else will be able to correct me on this, but in one of the big American legal cases to do with the teaching of intelligent design, they got Michael Roos, who's a sort of early sort of philosopher of biology, to come and be an expert witness. And it's super weird because they've got a sort of philosopher who's more or less talking the way I do. It's like, here are the 10 things that philosophers say make something a science, and then trying to use that to actually decide whether or not the claims that intelligent design people make. And that's just I would never get a philosopher to do that. We're way too principled. I think that the answer to this might be something like this, right? Well, I don't know, like this is a very tricky, but it might be that in certain contexts, these kinds of blunt instruments are useful for certain purposes, right? This is often how sort of lawyers think, right? Lawyers are often in the business of going, how can I use the legal resources that are available to me in order to, make the world work, I'm going to say better, in the way that this particular lawyer might want it to work, right? That's certainly how activist lawyers work. And I could imagine sort of using sort of some of these tools from philosophy of science as a kind of cudgel. And that, in fact, is in a sense what's happening in these debates we've sort of pointed to when the scientists start throwing Popper at each other. It's a kind of, maybe there are ways of doing that are kind of more legitimate. For instance, using them when you do have sort of pathological science, when you do have these cases where the science is kind of pernicious in these kinds of problematic ways, maybe then these things are fine to use. But there is a problem, of course, which is that you'll massively open yourself up to hypocrisy anytime you do it, because the person's going to be able to point at various activities you're doing and go, do you know what? That looks kind of the same to what I'm doing. Do you know what I mean? And so I guess it might be that if what you're looking for is a simple instrument that enables you to say, is this legitimate or not? Maybe the sort of machinery you get from philosophy isn't the right kind of tool, but maybe there are other bits of machinery, right? Maybe things like, I don't know, I'm blatantly thinking on the tip of my pants here, so this will make no sense, right? But maybe things like surveying people about the legitimacy of various research programs, right? Sort of getting a sense of what the, this is all highly problematic because what you're doing is you're deciding who the relevant people are in the first instance and then going out and asking them. But maybe if you can say 90% of the members of the Academy of Archaeology think that are willing to say that this is really bad. That could be some kind of approach. I'm not sure. This may not be speaking to what you suggest, speaking to the point you make, Alexander. But yeah, that was me waving my hands a bit.
Thank you.
Yeah. So do we have sort of further questions at this point?
I just wanted to add on that I thought that was really interesting what you said about pathological, science. And I think that really does characterize a lot of these kind of fringe pseudoscience, is that it's built out of a certain sense of psychological narcissism, right? Where the people, you wonder what motivates people who are flat earthers and things. There's clearly a certain psychology involved in how they've convinced themselves to go against the grain. There's more to it, not a genuine desire to find out about the world, but more of a, psychological sense of being special and being better than other people and knowing more than them and being in on a secret and those kinds of things. So I thought that was a really interesting point.
Yeah, no, I certainly buy the right way of understanding, at least as a sort of broad social pattern. It might be quite different for different particular individuals, but certainly a lot of those sort of conspiracy theory things should be understood sort of sociologically. A lot of it's about, socioeconomic conditions and so forth, so on and so forth. But also, I really buy the point, at least with certain movements, particularly with things like, flat earthers and things like that, that often what's going on is a certain type of identification, a certain type of finding a community, especially for people who feel like they don't really have communities. And I think so it's quite interesting. So maybe a further thing that you might add, given that, to the sort of the roll call of suggestions, is it's not what these people, it's a very othering way of putting it, what people who believe things like this need is not epistemic correction. What they need are communities. What they need is the right kind of sort of social situations. So maybe a much better thing to say is, don't futz around with the philosophy of science to answer this question, futz around with political philosophy and political science and sociology in order to answer sort of those sorts of questions. Let's go to the main room.
Okay, yeah, thank you very much. This was a very interesting paper. This sort of project, it seems to me that, as you pointed out, they are sort of pitching it to scientists, and it has this sort of normative component that it has to be useful to the scientists. I mean, one sort of problem is that it really hinges on the history and the details of the history, it seems to me. And I don't know history of this case at all. I mean, I know just a little bit. And one thing that strikes me, maybe on Thursday, I'll sort of ask the authors to sort of clarify a bit. I mean, it seems to me that this sort of a binary kind of a distinction, yes, dinosaurs, no dinosaurs, is really, I mean, it doesn't look realistic. It's probably very heterogeneous, or a bit more heterogeneous than they're not dinosaurs side of it. But I don't know, right? The problem is that the paper doesn't really give you any detailed sort of history.
No,
so
that's right. It's a very strange paper in terms of the way it's written, right? It's super somewhere between science and philosophy, where it does the thing that science papers do, which is assume a ridiculous amount of knowledge in the readers, where philosophers assume a lot of vocabulary, but we often sort of cash things out a lot.
Yeah, it's very hard to get right. I mean, I kind of write papers like this, so it's very, very hard to sort of balance it. But more.
I do want to come back briefly about that. I think it's like they are right to treat these as being very sort of starkly different hypotheses, and maybe I'll try and explain why. So when you're thinking about lineages of this kind of size, and you're thinking about it in this cladistic sense, which they are, then it's a little bit like asking are, there's a fact of the matter, I take it, about the relationship between sheep and horses, right? And there's a question about like whether sheep are more closely related to cows or whether horses are more related to cows. And the sort of question that goes, oh, well, maybe they're like sort of partially more related to cows and sheep.
Yeah,
is like,
I didn't really mean that. It's good that you pointed that out, because what I really meant is that you can arrive at that sort of stark distinction, right? Important from all kinds of sides of various alternatives. And then you kind of realize it's much more heterogeneous than we really think. I mean, I know that because we are dealing with similar situation in modern cosmology, and the debate looks very similar and so on. But one sort of philosophical question here that sort of came to mind is, when you sort of get tired of a certain program that you think is degenerate, like what are the time scales? How do we even determine that? I mean, is it like a year, 10 years, 50 years? And you can find counter examples for any hunch or intuition that you have. Like the one that Kevin Zollman sort of advertised is with the ulcer, the cause of the ulcer, and Helicobacter, right? The guys in Australia that were completely on the fringe, nobody believed them for like decades, and then boom, they got Nobel Prize. I mean, it wasn't as simple, of course, but I mean, it's really, really tricky to defend the sort of the paradigm, which is accepted. So it's
I think there's well, I'm not going to say an easy answer, but the answer I would like to give to that is to say, right, so what we learn from this is what we're not talking about is which hypothesis should I accept or not. What we're talking about is how should we distribute our epistemic resources. So if you look at kind of the sort of work that people like Kevin Zollman would do, it's like, hey, look, what we shouldn't do is everyone jump on the same hypothesis as quickly as possible, because if we do that, we might get unlucky and it might turn out we've been chasing sort of the wrong thing. And so the answer is, at least early on, distribute our epistemic resources more evenly. Then the question is, well, when do we give up on a question, and so on and so forth? I don't think we need to necessarily think of it in those terms. It's just about what payoffs do we think we might get from this research program? How expensive might that research program be, right? And so the question is like, hey, some people can, so my view, the thing I would take from this is, hey, it seems completely fine to me that there's a bunch of folks who are still going, well, what if birds are not dinosaurs, right? It doesn't seem, I mean, maybe it's hurting the community. Maybe the debate has gotten acrimonious in a certain kind of way. But when I thought about this, the ways in which scientists might disagree with each other, they can disagree with each other in this acrimonious way where the aim is to reach consensus, but you don't have to disagree like that. You can disagree by just doing different stuff, right? And so in that version where the scientists aren't fighting, they just happen to be working with mutually exclusive hypotheses. Like that doesn't seem to me like such a big deal if what we're doing is thinking about this as how to distribute our sort of epistemic resources. That's a very narrow answer. Given that we're just over time, we'll come back, go to the other hand once, and then we'll finish up.
I have a just short comment in defense of pseudoscience and bad science. I think we really need to have pseudoscience in comparison with normal science, because pseudoscience is full of bold hypotheses, and they are very weird, and we have crazy people there, but some of those bold hypotheses produce something interesting in the research. And I don't think that pseudoscientists are really a liability for scientific practice, because pseudoscientists and crazy scientists are very fast ostracized and marginalized by normal scientific practice, because I think normal scientific practice is very hard on people who have unusual hypotheses, and they are just doing and developing their weird hypotheses individually, and it's not really a problem of I don't know, focusing our epistemic strengths in scientific community, because pseudoscience is outside of scientific community. So I don't think pseudoscience harms scientific community. It harms people maybe because they are in the media and have presence sometimes, but scientific community is really not affected by pseudoscience.
Yeah, I suppose I've got three really quick things to say about this, but we should sort of finish. This is a fascinating sort of discussion to have. So one thing to say is that scientific communities are often extremely vulnerable, and they're vulnerable to sort of public opinion in various kinds of ways. And so even though I agree that pseudoscience often isn't in the discussion internally, as it were, to science, it can matter a lot because it can sort of have various deleterious effects on public perception of science. Another thing to say is, even though I have a lot of work on the importance of creativity and speculation in these sciences, and occasionally my work does get picked up by intelligent design people and things like this, because I say stuff like science is too conservative, and they go, see, look, Adrian's right, and this shows why people won't take us seriously, kind of thing. And my basic take on that is that I'm a little bit suspicious of the use of hypotheses that are that bold, right? I think that productive speculation is often less wild than that. Then my third thing, which is my sort of considered view, is something like this. Hey, if people want to go look for Bigfoot in the forest and it's not costing us much money, some cool thing might happen. That's fine, right? Like, they're not doing any harm on the face of it. The problem, though, is that you scratch a conspiracy theory for half a second and some really weird, creepy stuff starts coming out. The problem with conspiracy theories often isn't, in my view, epistemic fundamentally, it's often political. There's something about conspiracy theories that make them extremely vulnerable to being taken over by what are, in my view, just repugnant kind of political views. And so I think actually, in principle, if people want to go and do weird experiments to see if the Earth is flat, go for it. Like, if it doesn't cost much money, if it's only a few people doing it, then hey, that's like, why not make some long bets? Who cares? But I think in practice, these things are often, and I think it'd be interesting I'm sure there are sociologists who have tried to get a handle on this. In practice, these are often sort of conduits for much, much more pernicious kind of social forces, probably to do with the things we were talking about earlier about community and so on and so forth. But on that kind of weird thing, we should definitely finish. Thank you. I can see Thursday is going to be enormously fun. Thank you so much for coming along with this. And yeah, see you in a few days.